Hello student, welcome to my channel Learn Physics. I have already uploaded the video of the theory of Newton's laws of motion and forces. Now today I will be discussing the Ncert numerical of this chapter. So this discussion will be extremely helpful in your school exam and foundations of NEET, main and advanced. So let's start. Now first of all, formula used in this chapter. Look at this, v equals to u plus at, that is final velocity equal to initial velocity plus acceleration into time. Now displacement s is equal to ut plus half at square, and here v square equal to u square plus 2as, and finally force equal to mass into acceleration, that is rate of change of momentum, where momentum is equal to mass into velocity, and change of momentum is equal to final momentum minus initial momentum, and this is the conservation of linear momentum. And look at this, here v equal to minus mv by capital M, this is the recoil velocity of the gun. Okay, now Ncert numerical 5. A truck of mass 7 ton rolls down from rest to a distance of 400 meter in 20 seconds. We have to calculate acceleration of the truck, and finally we have to calculate force mass into acceleration. Now here u given, s given, t given, we have to calculate acceleration. Now formula, this is the s equal to ut plus half a t square. Now here s is the 400 meter, u is the 0, this is the 20 plus half into a is the question mark, and this is the 20 square. Okay, so look at this is the 400 equal to, this is the half into a into 400. Now this and this cancel out, therefore a is equal to 2. Therefore acceleration of the truck is 2 meter per second square. Now force mass into acceleration, look at this, force F equal to mass into acceleration. Here mass is the 7000 kg, acceleration is the 2, so this is the force is the 1400 Newton. Okay, understood? Next. Now Ncert numerical 6. A stone of mass 1 kg is thrown on a frozen surface with velocity 20 meter per second. The stone comes to rest after traveling the distance 50 meter. We have to calculate the retardation and force of friction acting on the stone. Look at this, here u given 20 meter per second, v given and s given. We have to calculate. What is the formula? Look at this, UVAS. So this is the v square equal to u square plus 2as. This is the 0 square equal to, this is the 20 square plus 2 into a into, this is the 50. Okay, so this is the minus 400, this equals to 100a. Therefore a equal to minus 4. So retardation of the stone is 4 meter per second square. Now force acting, mass into acceleration. Look at this, here m is the 1 kg and a is the minus 4. So look at this, here force of friction is the minus 4 Newton. As force of friction is the retarding force, that is why it is negative. Understood? Next. Now Ncert 7. A railway engine of mass 8000 kg pulls 5 wagons, each mass 2000 kg. By applying force 40,000 Newton. The force of friction on the track is 5000 Newton. We have to calculate net accelerating force and acceleration of the train. Look at this here, this is the accelerating force and this is the force of friction, that is the retarding force. So net acceleration force is the sum of this. Therefore, net accelerating force F is equal to, this is the F1 plus F2. Look at this, this is the 40,000 and this is the 5,000. So 40,000 minus 5,000. Therefore, net accelerating force, this is the 35000 Newton. What is the acceleration? Acceleration equal to net accelerating force by mass of the train. So look at this, acceleration is equal to the accelerating force, this is the 3500 by total mass 18000. This and this cancel out. Okay, so this is the 35 by 18 meter per second square. This equal to 1.94 meter per second square. Okay, look at this. A vehicle of mass 1500 kg have retardation of minus 1.5 meter per second square. What will be the resisting force? Look at this, the resisting force F is equal to mass into acceleration. So this is the 1500 into minus 1.7. This is the kg and this is the meter per second square. So this is the Newton. So this equal to 2550 Newton. Therefore, retarding force minus 2550 Newton. Okay. Now numerical 11. Two objects, each of mass 1.5 kg, moves with velocity 2.5 meter per second from opposite direction. Now, what will be the velocity of the combined mass if they stick together? So look at this, this is the conservation of linear momentum. This is the momentum of the first body, this is the momentum of the second body, and this is the combined momentum. So look at this, applying this formula we get, this is the 1.5 into 2.5 plus this is the 1.5 and this is the minus 2.5, this is the 1.5 plus 1.5 m1 plus m2 into v. Look at this and this cancel out. Okay, so this is the 0, therefore 3 into v, so v is equal to 0. So velocity of the combined mass after collision becomes 0. Okay, now Ncert numerical 13. Look at this, a hockey ball of mass 0.5 kg. It moves with velocity 10 meter per second. It is struck by a hockey stick and return the same path with 5 meter per second. Now we have to calculate the change of momentum. Look at this, the initial direction of motion is taken as positive. Now initial momentum P1, this is the mass into velocity. Look at this, mass into initial velocity. So 0.2 into 10, that is 2 kg meter per second. So this is the 2 kg meter per second. Now what is the final momentum? Mass into final velocity. So look at this, P2 is the mass is the 0.2 and this is the minus 5. Okay, so this is the minus 1 kg meter per second. Now change of momentum, that means final momentum minus initial momentum. So change of momentum delta P, this is the m into v minus u, that is P2 minus P1, this equal to minus 1 minus 2, so this is the minus 3 kg meter per second. Okay, understood? Now Ncert numerical 14. A bullet of mass 10 gram moves with velocity 150 meter per second. It strikes with a wooden block and comes to rest in 0.03 second. We have to calculate distance covered in the wooden block and retarding force acting by the wooden block on the bullet. So first of all we have to calculate acceleration. Look at this, here initial velocity given, final velocity given, and this is the time taken to comes to rest is also given. So what is the formula to calculate the acceleration? Look at this, here v is equal to u plus a into t. Look at this here, 0. This is the 150 plus a into this is the 0.03. Okay. So look at this, a into 0.03, this is equal to 150 with negative sign. Therefore, a equal to, this is the 150 negative sign divided by 0.03. This is cancelled out and this is the 100. Now this and this is the 50. So acceleration is the 5000 meter per second square with negative sign. Now what is the distance covered? Now distance covered s equals to ut plus half into a into t square. Look at this, here u is the 150 into t is the 0.03 plus this is the half into this is the 5000 and this is the 0.03 whole square. Okay, so look at this here, this is the 4.5 minus this is the half into 5000 into this is the 9 divided by 10000. This and this cancel out. Okay, now this and this is the 2. So look at this is the 4.5 minus this is the 2.25. So this is the 2.25 is the distance covered by the bullet in the wooden block. Now we have to calculate force. Force is equal to mass into acceleration. Look at this is the mass and this is the acceleration. So here 0.01 into negative sign of this is the 5000. So this is the Newton. Therefore, this is the minus 50 Newton is the retarding force acting on the bullet by the wooden. Now Ncert numerical 15. A body of mass 1 kg moves with velocity 10 meter per second. It collides with another body of mass 5 kg at rest. They stick together. We have to calculate the total linear momentum before impact and after impact, and we have to calculate the velocity of the combined mass, that is m1 plus m2. Okay, now total momentum just before impact, this is the m1 u1 plus m2 u2. Okay, so this equal to 1 into 10 plus 5 into 0. So this is the 10 kg meter per second. Now we have to calculate the total linear momentum after impact. From principle of conservation of linear momentum, the total linear momentum before impact and after impact are same. So total linear momentum after impact is also 10 kg meter per second. Now what will be the velocity of the combined mass? Look at this, as total linear momentum after collision is 10 kg meter per second. Now we have to calculate the velocity of the combined mass. So look at this equal to m1 plus m2 into v. Okay, so look at this is the 1 and this is the 5 into v. So v equal to, this is the 10 by 6, that is 5 by 3, that is 1.67 meter per second is the velocity of the combined mass. Okay, understood? Now Ncert is 16. A body of mass 100 kg is accelerated from velocity 5 meter per second to 8 meter per second in 6 seconds. We have to calculate the change of momentum, that is final momentum P2 minus initial momentum P1 equal to m into v minus u, and we have to calculate the force acting on this body. Now look at this, here u given, v given. So look at this initial momentum, this is the mass into velocity, final momentum mass into final velocity. So look at this, P1 is equal to, this is the 100 into 5 kg meter per second. P2, look at this is the 100 into 8 kg meter per second. So change of momentum delta P, this is the P2 minus P1. So this is the 100 into 8 minus 100 into 5. So this is the 100 into 8 minus 5. So this is the 300 kg meter per second. Okay, understood? Now we have to calculate force. Here U given, V given, T given. So we can easily calculate acceleration. Now what is the formula? V equal to U plus A into T. Here V is the 8. So this is the 8. U is the 5 plus A and T is the 6. Therefore 8 minus 5, this is the 6A. Therefore A equal to, look at this is the 3 and 6. So this is the 3 by 6. This is the 0.5. So what is the force acting? Mass into acceleration. Here mass is equal to, look at this is the 100 kg and acceleration 0.5. So this is the 50 Newton is the accelerating force acting on mass 100 kg. Okay. Now Ncert numerical 18. A dumbbell of mass 10 kg falls from height of 0.8 meter. We have to calculate momentum transferred by the dumbbell on the floor. Okay. Now look at this. Here height of fall is given. Acceleration due to G is also given. Initial velocity 0. We have to calculate final velocity. So what is the formula? Look at this. Formula is the V square equal to U square plus 2GH. So look at this. Here V square equal to U square plus 2GH. Here V square, this is the 0 square, this is the 2, G is the 10 and this is the 0.8. So this is the 16. So this is the 4 square. Okay. Now V square equal to 4 square. Therefore V equal to, this is the 4. Okay. Now momentum is the mass into velocity. So momentum just before impact on the ground, P is equal to, this is the mass into velocity. So this is the 40 kg meter per second. Now this momentum is transferred to the ground. So momentum transferred to the ground is equal to 40 kg meter per second. Okay. Next. Now additional numerical 1. Now look at this is the time and this is the displacement. Look at this 0 0 1 1 2 8. Look at this is the equal interval of time, but distance increases more rapid, therefore velocity increases. So it is uniform motion. As displacement increases more rapid, so its velocity increases, and as well as acceleration also increases. If acceleration increases, then force acting on the body is equal to mass into acceleration. So as acceleration increases, so force acting on the particle is also increases. Therefore, the body has non-uniform velocity, non-uniform acceleration and non-uniform force acting on it. Okay, understood? Next, look at this is a car of mass 1200 kg. When it is pushed by 2 persons, each applying force F, then it moves with constant velocity. That is acceleration 0. That is accelerating force 2F minus force of friction is equal to 0. So here 2F equal to small f. Now when this car is pushed by 3 persons, each applying force F, that is net force 3F, it moves with acceleration of 0.2 meter per second square. Now when 3 when 3F force is applied on the car, the net force, look at this F dash, this is the 3F minus force of friction. Here force of friction is equal to 2F, so this is the 3F minus 2F, so this is the F. This net force produces acceleration of 0.2 meter per second square. So what is this? This is the mass into acceleration. Look at this, this is the 1200 into 0.2, so this is the 240 Newton. Okay, therefore force applied by each person is 240 Newton and force of friction is equal to 480 Newton. Okay, now A3. A hammer of mass 0.5 kg falls on a nail with speed 50 meter per second and comes to rest in 0.01 second. We have to calculate the force acting on the nail. Look at this, here U given, V given and time given. So here V equal to U plus 80. This is the 0 and this is the 50 plus A into this is the 0.01. Therefore minus A into 0.01, this is equal to 50. Therefore A equals to 50 by 0.01. This is the minus 5000 meter per second square. Okay. Now look at this, the force acting on the hammer. Now force on the hammer F equal to, this is the mass 0.5 into 500 with negative sign. Therefore this is the 2500 Newton, negative sign. So force on the hammer is minus 2500 Newton. So force on the nail is the positive sign of 2500 Newton. Okay, understood? Many thanks for watching this video. I hope this video will be extremely beneficial for your school examination as well as foundation of NEET, main and advanced. Please like, share and comment on the video, and to learn physics easily, don't forget to subscribe my channel.